That's the Neuromore Studio. It's like our development environment for experiences. What we created is the node-based visual programming way for biofeedback applications. To give you a quick example of how a simple protocol can be created, for instance, if we use the muse, we just drag it in. And then let's say we want to extract dominant frequency. To be able to do that, first of all, we have to convert the signal from a time domain as it's coming into a frequency domain, and that kind of like means that currently, so that's the raw data as it comes in. That raw data has like time on the x-axis. So what we currently have is like a connected sensor, a muse. We take the data that's coming in from FP2 and FP1, and then convert it from the time domain to a frequency domain. We have a node for dominant frequency, so what we could do here is like say, well, give me the dominant frequency in an alpha range. We created here, for instance, it's like a simple protocol that uses FP1, FP2, extract dominant frequencies, and for dominant frequencies we have to also define a range, so we just look at the dominant frequency between 2 and 40 hertz and output that to feedback score. Feedback scores is everything that's the result of a certain protocol it could be. So feedback score is kind of like a number. If you start a game, all the feedback scores are being transmitted to the simulations that we're running on the lower side of that simulation, and the current values on the left side. Also, there's another window of feedback, and that window of feedback initially just displays like the feedback score. First feedback score in that particular game is mapped to the speed of the tunnel, so that would be based on that protocol is like alpha beta ratio, so the higher alpha compared to beta gets, or the stronger, the faster you're going at that tunnel. Like for that game, like the second feedback score that you feed in has an impact on the color of that tunnel, so that would be the zeta beta ratio. So based on those two like feedback scores, you can create a protocol using that that tunnel simulation. So also the games like immediately react in real time to a change in protocol, to a change in the number of feedback scores, and so on. So you can keep on playing the game even if there's like multiple feedback scores coming in. As we in that particular protocol just have one feedback score, the only thing we can control currently is the speed. We would have to add another feedback score to be able to change the color. So we just change the feedback score index to 1. Now map the relaxation to the color. Now we have the second feedback score, and so based on how it's set up right now, that feedback score is mapped to concentration, so we can also rename those feedback scores in real time, and the second one is called relaxation. The first one impacts the speed in the tunnel, and the second one changes the color in the tunnel. And now you want to see what's really going on with that person. And then we provide you with all different kinds of like data visualizations. And I also see that being pretty beneficial for a lot of different applications. And all that can be done while people are still playing the game, or while someone is still like doing his neuro biofeedback training. And once you enable that data upload to our cloud system, it can be set up here, upload physiological data. Once that is checked, that means that all the data that has been collected will be uploaded to our cloud system. If you have that enabled, then you can just click here and show reports, which directly sends you to your user. In that report, there's all different feedback scores, so it's completely generic. So whatever kind of like feedback scores you have in your classifier, and however you named them, that's exactly how they will show up here. You're really like looking at it. We keep that report. You can print it out or look at it at a later time.